Thank you so much. Uh, Welcome back, everyone, after lunch. Uh, Speaking of sessions, today has been great. Lunch is also one of the exciting sessions of the day. Not because it's lunch, but also it gives a chance to ask all the unasked questions during the sessions without time limit, with a focused audience. I really enjoy and yeah, cherish those sessions. I hope you had a good one as well. And some of the sessions you couldn't ask. A lot of you raised hands. Michael had a lot of inputs. He wasn't able to get in because of time, but hopefully you got a chance to do that during lunch. This session will be very brief. As we had hoped, we cannot get too much under the hood, but we'll cover at a high level what's coming with Mojaloop next version 17.2.0. And then I'll pass on to James to talk about Mojaloop upgrades and the various aspects of that and things that come with it. My name is Samuel Kumari. Apologies that I couldn't join you in person today, but really glad that I'm able to make this presentation announcing version 17.2.0, and I hope I can join in person and meet you, some of you whom I haven't met before at a future event. So today I have about 10 to 15 minutes, unless James, you can interrupt me if we are out of time, but I have a timer. And we want to look at Mojaloop version 17.2.0 at a high level and see what comes next after that. So the release details, and want to lay the foundation for what's coming next, not just in the future and from a product standpoint, but speaking of upgrades and the intermediate future. We have another session, I think Paul covered earlier, a longer term future, but this will be focused on the here and now. A quick snapshot of where we are in terms of Mojaloop evolution. I think we've seen a few of these, one earlier in the day as well. But want to focus on the last three here, version 17, 17.10, and 17.2.0. Version 17 obviously is like a turning point in Mojaloop in terms of Mojaloop releases. We had two new use cases, FX interscheme and ISO 20022 support that was delivered to the community through that version. And then we had a consolidating release, version 17.10, with some initial fixes, Node.js upgrades, quality improvements, and the usual in that. And now version 17.2.0, which builds on that as well. And I really like the release. We've done extensive bit of testing on this one. And recently we did a product council session where on the technical side, we showed how the upgrades can seamlessly be made. We deployed a version 16, tested it. Surprisingly, all the tests are still running fine. It has a 100% pass rate. And then we upgraded to version 17. And even all these versions, version 17.1 and 17.2, especially 17.2, will work fine. And we've tested the upgrade as well. Another reason is, I'll cover this when we get to the features, but this is, in my opinion, a very important release to get to make sure that taking advantage of some of the registry changes and are not hampered by the changes made, which are outside of our control. Mojaloop platform at the core is what we are talking about. When we talk about a Mojaloop release, it's about the core release, but of course, the platform itself consists of several layers, the supporting services and connectors that sit outside of that. And then of course, the overlay services like monitoring, operation support, finance portal. And then of course, on the platform at the outer layers, we have the security API gateway levels as well. Version 17.2.0 from a use case point supports the usual set of use cases. Early this morning, we saw Miller mention 13 use cases. Incidentally, it's also 13 use cases in the FSP op, but those also break down the cash in, cash out, and merchant and point of sale devices. But yes, all these use cases that we discussed before are supported out of the box. Some configuration change will be needed to enable some of them. Some of them are enabled by default, the simplest ones. And with the version 17.2.0, that is the case. We ensure that we are always making sure all the use cases that are supported in the previous release are supported as well. In some cases, we do fix and enhance those features. but we have test collections testing all of these separately. For example, the peer-to-peer, request-to-pay, which includes merchant payments, and the bulk are all supported. They have their own collections. We have a golden path collection. We call it golden path because that touches the critical path and most of the important and widely used scenarios. But we also have collections for each of the other use cases as well. Some of them actually including the components that we deploy on the TFSP boundary, what we call the SDK scheme adapter. We also have FX and interscheme that is supported with further enhancements now and some bug fixes, and of course ISO 222 messaging. We also took advantage of the effort done as part of the performance white paper that has been working for the past few PIs and the learnings from that, and included some guidance. So the repository there and even the release notes talks about the configuration options that can be used. And if you go to a performance white paper repository, which is public and for any users, read-only access is available for anyone, even without logging in. But it also talks about the detailed scenarios on the resource usage, the scaling requirements, the configuration options. It also has the scripts. So all the information required and the information that we used ourselves to come up with those tests and numbers are all published there. So all this comes as a package for version 17.2.0. Of course, this is the core. We saw that, and on top of this, we have the other overlays and services to build on that. The usual use cases for settlement are still supported, deferred net continuous gross with FX support. Version 2 is the settlement version supported now, and version 3 is something that we have in the pipeline for the future. Similarly, participant lifecycle API version 1 is supported. There are changes that are being discussed, enhancements as usual for version 2. Third-party payments version 1 is currently supported in v17.2.0. V2, there is a work stream that is implementing the PISP version 2 of the API, which will come in the near future. So the ISC bundle includes the core and then the rest of the services that provide security. Most of the services needed for deploying a production quality Mojaloop are included in the bundle, and this can be used as a reference for deploying a production quality system of Mojaloop. You can see that a lot of these components support deploying like security components, but also things that are required usually following best practices for security, resilience, and reliability. The next few slides go into detail on the use cases and the resources. So I don't want to cover everything, but you can see that the highlighted parts here are the ones that we touched during the past release cycle. So I'll just I'll just browse through this. And this is the slide I want to spend a bit of time on. In version 17.2.0, we can see that we have improved performance and enhancements to existing features. For example, there was some changes made to the logging in some of the components. Though we are looking, so one of our community member entities is working on a logging framework. It is yet to be discussed at the design authority, but we have it on the pipeline to come to the DA and to be adopted. We are hoping it will be part of the future release version 17.3.0, even before we have a bigger release with the Tiger Beetle integration. Along with this, we also have the learnings from the performance. So on the code base, application code base itself, there haven't been too many changes, but it's more on the configuration options and the tuning that our lessons are now published. So we also have a performance white paper published, but also in the performance related repository itself, all of our configuration options and the testing methodologies, scenarios, architecture are documented, which can be very useful with this release. As usual, this release has enhanced security. We have the dependent modules that are upgraded and patched as necessary. Like we use several tools. We use scan.
Apologies everyone, we're having a minor technical issue. Please bear with
Made by our
us.
community members with regards to FX and interscheme. There are also improvements to logging and lookup as well, as I've mentioned before. Let me take a pause there. If there are any questions, I'm thinking James will take over after I give a brief update on the release, and we can likely take some questions after that. But after I'm done presenting, if there are any questions on Zoom chat, I can take those as well. Another thing which we did not have in our control is for those of you who are familiar with Bitnami. So Bitnami made a decision a year or so ago to in simple terms, make itself like a subscription-based registry. They still support a free service, but right now it is called, these images are not supported. They say that they are not patched. So the images are still there in a repository called Bitnami Legacy, but the Bitnami itself now has hardened images, but we have to pay for it. And at Mojaloop, we don't want to use subscription-based components. So we had to first fix it to change the Bitnami references to Bitnami Legacy so that at least they work. But we're also in the process of moving to other registries. So there are proposals now at the DA to be discussed. Hopefully we can discuss it next week or in the coming weeks to move each of these into more standard registries and Helm charts as well. So that is a big issue because of this change that Bitnami made. What happened was that the previous releases that use Bitnami will no longer have access to their images. So these may not work, especially in some of our init containers where Kafka-based images are used. This will not work and they will need manual changes. So where the community members and adopters are using Mojaloop example backend as reference, or just the example backend as it is, these changes will have to be mandatory. It's not in our control, but that is the nature of open source. So we have to keep an eye on this. So that is one of the significant, even though low-key changes that is implemented with version 17.2.0. And of course, version 17.2.0 prepares us for changes that are coming in the future. We know that there are changes coming to the logging framework. Tiger Beetle integration is coming, and we'll have more performance improvements. So the performance white paper work stream is resuming. So we have fixes in the pipeline that are coming. I'll take a brief look at the release notes, and we'll go into the roadmap and then wrap it up. So if we go to, let me see if I can share my browser window just for a minute. So here you can see, if you go to this, I'll also drop this in the chat, Zoom chat window for those of you online. And for those of you who are there, you can just go to Mojaloop GitHub, in that the Helm repository and releases, and the top one will be the Mojaloop version 17.2.0. So version 17.2.0, you can go, this is quite comprehensive. You can look at the various sections here, starting with the summary, which we've covered here. And there is an exhaustive list of the bug fixes and the new features implemented, application versions, API versions used, testing notes and recommendations, and then the various configuration options, because you'll need to customize it to your own needs. And towards the end, credits, contributions, known issues, and a section for breaking changes as well. We don't have any for this one. With that, I'll just have a few more seconds on what's coming next, and then I'll pass on to James. Just give me one more moment, James. So this is the release cycle. I'll leave it in the section here. A roadmap of our most recent releases before version 17. We have 15, 15.1, 15.2, 16, 17, then 17.1.2, and then we'll have a 17.3 and likely 18 after that. We want to continue performance profiling and the deployment improvements. We want to work on IAC to ensure it supports our latest release as well. And want to prepare for the upcoming releases, version 17.3 with logging improvements, with improvements in performance, but also a bigger change coming with the change in the underlying ledger to use Tiger Beetle. These are the various things we have in the pipeline. If there are any questions, I'll be happy to take after James's update as well. thank you everyone for listening. James, over to you.
So we'll take questions at the end of this session, but we'll try and make our way through the next couple of presentations quite quickly. Would you mind switching to my slide deck? Now, unfortunately, I'm the type of presenter who needs to read his slides as I present. And the very small screen over there is far too small for my eyes to see, so I'm going to have to look up at the big screen to read as I talk. Here we go. Thank you. Okay. So Sam was talking about the latest Mojaloop release. I want to spend a little bit of time talking about what happens to that release. If you're a user of Mojaloop, an adopter as we call them in the Mojaloop community, you will have noticed that Mojaloop releases come along relatively frequently. We have 3 major releases every year that coincide with our program increments, our PIs as we call them. But in between those, if there are a significant number of security patches or bug fixes or critical issues that need resolving, we make intermediate releases. Recently, we have become aware that not everybody in our markets are familiar with dealing with software releases that come this quickly. Lots of people in financial institutions will be used to doing software platform upgrades, maybe as infrequently as every 2 or 3 years. Mojaloop was designed from the ground up to be cloud native, and that comes along with some unique opportunities and risks that need to be managed. So hopefully I'm going to try to illustrate some of those as I walk through my slide deck, so you can be a bit more informed, help you make some decisions, understand how you can make the most of Mojaloop's frequent change process. I just need to try to find the little slide dongle. Give me a second. Thanks, Tilo. Okay, so deciding on your upgrade strategy is quite important. National payments infrastructure has to balance the stability of a very impactful, wide-ranging, critical system with the ability to innovate, to make changes, to make things better. Mojaloop exists to improve instant payments. If we're going to make use, take full advantage of those Mojaloop features, we have to figure out how to keep changing, while at the same time minimize the risk of breaking things as we go. So there are different approaches that are typically used in large software-based information systems. But the types of things that we need to worry about include service reliability, the risk of our operations changing, how expensive that is for us, but at the same time, how able are we to take use of the new features and bring new solutions to our market. Very much we hope Mojaloops will become the fundamental underlying rails, national payment systems. If that's true, they need to be super, super reliable. So making upgrades sounds like a very scary and risky thing. So we need to figure out how to do it in a way that minimizes the risk, but also helps us take advantage of the new features around. In this deck, I'm going to highlight two opposite ends of the spectrum, more traditional infrequent upgrade cycles that people who manage core banking systems might be familiar with, where your major upgrades happen quite infrequently, every 6 to 18 months, maybe even longer, 2 or 3 years sometimes. And those upgrades tend to batch together a large number of changes in one big upgrade. They tend to happen in very pre-planned intervals, so you have lots of time to prepare to manage the risks associated. On the other side of the spectrum is a more I'm going to say modern because it's not been around quite as long as the traditional approach. Continuous deployment. Continuous deployment is a thing that's evolved over the last couple of decades, really because of the availability of infrastructure as a service in cloud environments. Large organizations like Google, Meta, realized that in a cloud environment, they could increase the frequency at which they were upgrading their software platforms by introducing some clever risk mitigation techniques. Okay, so a bit more detail on more traditional upgrades. These, like I say, happen less frequently. They include a large number of changes, but they typically enable a very thorough, long, drawn-out testing cycle. Historically, most of that testing would have been done manually by humans pressing buttons in the interfaces running through test scripts to ensure that the system behaves as expected before the upgrade is signed off and then released into production. If you have a vendor, vendors are often heavily involved in the upgrade cycle of your platform. Quite often they dictate the frequency at which you upgrade your platform. That kind of suits them, but it doesn't really suit you if you need changes in your platform quickly. You want to release new features or fix issues. You don't want to have to wait 6 months for the next release cycle. However, there are some advantages to doing things this way. You do have a large degree of predictability in your upgrade schedule. It's easier to govern the change cycle because it happens less frequently. You can spend more time thinking about it, managing the risk. This type of model is certainly much more familiar to regulators and financial institutions because of the traditional longer quality assurance and certification programs associated. However, as I already mentioned, bundling a large number of changes into a single upgrade increases the risk that you're going to break something. The costs of running these upgrades are typically much larger. There's a large amount of accumulated risk in deploying a very large number of changes into a production environment. So you have to spend longer making sure nothing breaks. Technical debt can accumulate quite rapidly between longer release cycles. If there's a known issue in your platform, your operations team might have to adapt, develop some workarounds. Those can lead to technical debt existing. And as that technical debt builds up when a release happens, your operations team have to adapt very quickly to a large number of changes in the way they have to work, which can be painful and costly and risky. So the alternative, continuous deployment. This is usually very small incremental updates. Typically, in cloud-native platforms, any change that a developer pushes into the source code repository runs through a pipeline and ends up in production within sometimes a matter of minutes or even hours, but certainly multiple times a day is typical for a continuous deployment cycle. Obviously, there's a very strong reliance on automation in this type of process. You can't have a team of testers pressing buttons on screens to make sure nothing's broken in the software. You have to automate your testing. Some of you in the room may be familiar with the term DevOps and CI and CD. These are associated with this continuous deployment model. That's part of the way of making sure that you don't release a broken change into production. So you'll notice this is often used in cloud-native platforms, software as a service offerings, and platforms that follow the microservices architecture. Mojaloop does follow the microservices architecture. So this is quite a nice fit for Mojaloop. We have less risk per change if we follow this model, because we're releasing one small set of changes to the software code. This means not only can we release changes faster to our customers, but we have a shorter backlog of changes. We don't have a big long list of things that we want to release. Everything gets released to the customer in small cycles. Easier root cause identification. This is an important one. If you release a very large number of software changes all at once and you find a problem, something goes wrong, it's quite hard to know which one of those changes caused that issue. It's a much harder debugging problem if you have 1,000 changes rather than a single change. As I said, you need mature automation and testing. It's slightly harder for operational teams because their world changes much more frequently. Every day they might have to adapt to new changes. So your ops team needs to be quite embedded and close to your development team. So you're very much in sync across the entire organization with the changes in the product roadmap. The risk profile is very different for these two approaches. Obviously, in the traditional model, there's a higher risk per upgrade, but there's a lower frequency of operational change. With continuous deployment, obviously, you have lower risk per release, but because they happen much more frequently, your operational change is constant. So an important takeaway from this is the shift of risk that happens when you move from this traditional model to continuous deployment. So how do we mitigate the risk when we're making deployments into production very frequently? A number of adopters who we talk to, central bankers, financial institutions, they have to be very risk averse. The idea of making production releases several times a day scares a lot of people in these organizations. But luckily there are some techniques, some tools that have been widely used by the biggest tech companies in the world for quite some time now, several decades, to mitigate those risks. One of these is called blue-green deployment, but you can substitute any two colors you like in there, really. It's just commonly called blue-green. What this means is at any one point in time, you have two production sets of infrastructure. One that's running live currently with your customer traffic being routed to it, and the other one that's kind of idle. As you wish to make a release to production, first of all, you deploy that software into the idle infrastructure. You perform some automated tests on it, and once you're sure it's able to take the traffic, you cut over from the old system to the new system, and you observe it very closely. The major reason for doing this is that if you spot an issue, you can very quickly flip the switch and push your traffic back to the original platform. So it gives you a very fast, instant rollback capability. It's a really good risk mitigation. However, it's more expensive because you now have to have two production infrastructures. So again, there's a compromise there, cost versus risk. Another option, canary deployments. This is where you roll software out gradually to a small subset of your customer base. So again, you need two deployments, but your second deployment can be slightly smaller to begin with, and you can elastically downscale your current production and upscale your new deployment production instance as traffic gradually gets cut over from one to the other. This allows you to incrementally test how your new system behaves with a certain subset of your customers. In Mojaloop terms, that might mean switching one or two DFSPs over onto a new version of the platform, while the others carry on running as normal. If you observe no issues, you can slowly cut customers across from the old platform to the new platform. And with both of these approaches, observability is really important. you need to be able to see if you have issues, if customers are having issues. Are the messages still passing through the system? Is the money still moving? You need to be able to see that live in real time to know if you've got an issue. So there are also considerations for your DFSPs. So if you're a hub operator and you're thinking about these different upgrade strategies, you need to have a think about your participants. What regulatory approval process do they have to follow? What regulatory approval process do you have to follow? Is that compatible with multiple releases per day? What's the certification cycle? What's the test cycle? These are all questions you need to ask yourself. You need mature CI/CD, as I've already mentioned. How good is your automated test? How reliable are your rollback mechanisms? Observability and monitoring, as I already mentioned. How well is your ops team trained to cope with these frequent upgrades? These are all things you need to think about. But typically, continuous deployment models require a higher level of operational maturity. So the infrastructure architecture does affect the feasibility of both of these models. If you have the ability to have two production systems or not. But luckily, the Mojaloop microservice architecture is flexible enough to support either of these. So if your regulatory environment or your risk management requires you to make less frequent software updates, that's just fine. Governance, as I've also already talked about slightly, change approval process. Regulators help you manage your risk typically. And sometimes they help manage risk in a broader context of a national economy, for example. So they might have strong opinions about the risk profile that you adopt in your software upgrade cycle. So it's important to have good conversations with your regulators. We're hoping that the world will shift to a point where regulators are less concerned with managing risk per upgrade and more concerned with certification of an organization's ability to manage those risks through a continuous deployment lifecycle. Time will tell there. Cost structure as well. Traditional upgrades, bundling everything up into a few large releases, has a certain cost profile. The testing is expensive, the risk is large, but you make savings because your operations don't have to adjust quite so frequently. You have to work out how that balances against the other side of the coin with a continuous deployment model, the lower per release cost, but the higher investment that's required in automation and making sure your operations team are able to manage this process. But one strong key takeaway there, automation will reduce your cost. You don't have to choose one or the other of these two approaches, obviously. There's a middle ground. So some adopters may choose to adopt security patches very frequently because they're important. The risk profile of not adopting a security patch from an open source dependency is different to the risk profile of introducing a new feature to the market. So you have to think very carefully about which of those you're willing to accept and how often. Feature flags is a thing that has been talked about in the Mojaloop world for quite some time. The Mojaloop microservice architecture and the way the APIs are designed with versioning support mean it's actually possible to run several versions of any given Mojaloop service in your infrastructure at any one time and route the traffic appropriately. So you can actually choose to switch on or off different versions of the Mojaloop services during an upgrade or during your normal day-to-day operations to help you manage that risk profile. So what questions do you need to ask yourself when thinking about software updates? Which of these models or some other model that might be appropriate for you, how do you figure out what to do? Well, you need to take a close look at your operational maturity. How well could your team cope? How well do they understand the Mojaloop CI/CD process? How are they able to adopt that CI/CD process internally? How much of the Mojaloop automation testing can you get running in your environment? How well can you set up your operational technical dashboards to monitor your platform? How frequently do you want to release new features if you're confident that your platform is going to be stable for a year? What are the advantages of upgrading once every 2 months to pick up the latest security patches? What are the risks of not doing that? So I think I'm coming to the end here, but I just want you to be aware that these options exist out there. Mojaloop architecturally supports either of these. It's up to you to figure out what works best for you. But I would like to say, don't be afraid of continuous deployment. Take a really good, close look at that. There's a whole ton of research, papers available on the internet, case studies to show you how canary deployments or blue-green can be done, particularly with our infrastructure orchestration tools, Kubernetes. It's very well documented. And like I say, the optimal strategy that you'll likely end up with might not be strongly on one side of this argument or strongly on the other side. It might be somewhere in between, and that's absolutely fine. You have to figure out what works for you, but be sure you understand the risks on both sides. Which risks are you taking by doing infrequent updates? Which risks are you taking by updating several times a day? You have to understand the risks to manage them. So maybe if you go away from this session today, there's a couple of questions you can ask yourself about your operation that might help you figure out the way to go. Okay, I think that's the end of that slide deck. But while I'm on the subject of upgrades, I do just want to take a minute to talk about one particular important upgrade that's coming very soon to Mojaloop. Version 18 of Mojaloop will have a Tiger Beetle ledger instead of a MySQL-based ledger. I won't go into the technical details of that today. There's lots of material in the Mojaloop ecosystem, and we've talked about it at several MojaComs before. It's very close to its first community release. I have a short video from Lewis Daly from Tiger Beetle to show that I'll ask the guys at the back to queue up for us. And before it starts, I'll just introduce Lewis. He's a very long-term Mojaloop contributor. He's been there since the very early days. He now works for Tiger Beetle. Tiger Beetle database was designed specifically to fix one of the core performance limitations at the heart of Mojaloop. It's a very nice product. We're very much looking forward to having this.
Hi there. It's a pleasure to share an update on the work that we're doing putting Tiger Beetle into Mojaloop. Tiger Beetle is a transaction processing database optimized for safety and performance. What we're doing is putting Tiger Beetle alongside the existing MySQL general purpose database. Where before we had the general purpose database handling transaction processing, once we're done, all of the transaction processing will be handled by Tiger Beetle. Our goal is to reach API parity. Users will be able to take Mojaloop off the shelf and run with Tiger Beetle, unlocking the safety and performance guarantees while minimizing the number of breaking changes. So I'm pleased to say that in the last 6 months, we finished integrating the 3 Mojaloop APIs, the admin, the FSP IOP, and the settlement API on top of Tiger Beetle. We're currently busy at work splitting up all of the changes into reviewable pull requests that live on the branch in Central Ledger called Tiger Beetle Ledger. So far, we have 2 pull requests merged in, 1 in review, and a number of upcoming PRs. We've also been able to remove 2 dependencies from Central Ledger, and we're always on the lookout for more. We're also modernizing the testing infrastructure, moving to the native Node.js testing runner. Let's talk about performance. So previously, on Tiger Beetle Racing, I demonstrated Tiger Beetle Racer, our benchmark visualizer, and we raced both Mojaloop running on top of
We've lost audio on the video. Could we maybe pause the video so we don't miss any of the audio?
and then doing that same thing but in reverse.
Okay,
That's
can we
payment.
pause the video and go back, please?
See the performance differences between 2 different implementations. And what we do is we run the Mojaloop switch and send in as many payments end-to-end as quickly as possible and count how many are completed per second. That's transactions per second. And the maximum time it took any payment to go through, that's the latency. A payment is a message going from the payer DFSP to Mojaloop and then onto the payee DFSP, and then doing that same thing but in reverse. That's 1 payment. 6 months ago, we demonstrated massive latency improvements going from a maximum latency of 8 seconds end-to-end to 3 seconds end-to-end. But the question still remained, what are we doing in these 3 seconds? So over the last few weeks, we've been adding some improved tracing, which looks something like this. And now we can see the biggest drivers of latency are writing to and reading from Kafka, and then writing to Tiger Beetle. This is all helpful information for future performance work, and we've used it already to tune that latency from 6 months ago. So the question is, are you ready to have a race?
Yes.
So today we're going to be debuting a new track, Galactica, and we're going to race the current Mojaloop integration from a few days ago against the integration from 6 months ago. Let's go. I want you to keep track of both the TPS that's in the dials, the red and blue dials, transactions per second, and then latency, which is going to see in the middle. And ready, set, go. So already out the gates, the current integration is ahead of that of 6 months ago. We're seeing the transactions per second is consistently higher, but the most important thing is that our end-to-end latency now is under 1 second. And there we go, we have a winner. So, that concludes our little performance update on the Mojaloop evolution workstream, and hope you enjoy the rest of your convene.
Yeah, thank you. Thank you. I love the Tiger Beetle videos. They're so great. I would just like to extend our very grateful thanks to Lewis and everybody at Tiger Beetle for the work they're doing here. That's everything I have to say for now. So at this point, I'm going to hand over to Ploon. I think maybe we have time for 1 question from the floor if anyone has anything. Julie at the back there, you were first with your hand up.
It's not really a question, it's more a comment and a plug for the performance white paper which
yes.
has now been published. So perhaps, James, would you mind to comment a bit more on this?
Yes, thanks, Julie. Yes, those of you who've been paying attention for the last year or so will know that we've been building a white paper to explain the performance characteristics of the Mojaloop platform. That has now been published. It's available on our website. It's quite comprehensive. It covers a whole bunch of different testing scenarios. There's some good data in there, some good takeaways, and a couple of real-life use cases for you to get your teeth into. Please have a read of it. That workstream is still very much in progress. We are going to iterate that white paper and continue adding new data to it as the workstream progresses. Okay. Thank you. Where will you find the white paper on the website? That's a very good question, Miller. I actually looked for it yesterday and couldn't find it. Does anybody know which page it's on?
Yeah, I'll share the link on Zoom chat here.
Sam shared the link. Thank you, Sam. Yeah.
Sure.
I think it's on our Community Central, as well as the main Mojaloop.io website in one of the sections there. If you can't find it and you would like to read it, please reach out to anybody of the Mojaloop staff here and we'll get you the link directly. Okay, thank you very much. Back over to you then, Pleen.